Alright guys, welcome to Unit 4.3 and 4.4, which are all going to be about nested loops and lists. So, let's kind of just get started here. What is a nested loop? So it's going to just be anything where you have a loop running inside a loop, which means obviously that one of them is going to be blocked until the other one can finish, right? So to give you a quick demo of what this would look like, let's say okay, so let's say like when we're working with for loops, typically I is used as kind of the iterator object or like the number that we're going to be tracking. So if I just say like I or for I in range, let's go 10 here. Okay, so remember that if we declare a range with one parameter like this, this is going to start at 0 and go up to 9 because that's going to be 10 objects in here. So it's going to be, this is the second parameter in range, which would be up to but not including, right? Okay, so if we put a nested loop in here, typically you're going to use J because we're just going to go in ascending alphabetical order. So let's kind of do the same thing, right? Okay, so this would be a nested loop at this point. But we need some content in here, right, I guess. We'll get to that in a sec. So this is a nested loop, so this one is running inside of this loop, which means that this one is going to have all 10 of its iterations every time I has a single iteration. So to kind of demonstrate this, let's just put some prints in here, and then I'm going to do something else up here at the top. So I'm going to import this package called time. And this has something in here that allows us to kind of, like we're going to be, what I'm going to be using is the thread sleep, which allows us to kind of put a wait in Python, because normally when you execute this stuff, it happens so fast you can't see anything that's happening. Well, here, let's just do this to start with. Okay, so I'm going to print I, and then for every one of these, I'm going to also be printing out every value of j, and show you what happens without any of these thread sleeps. Let's put a tab in here so that this one, so that way we can kind of just see this a little bit more clearly. And then I'm going to use an f string and put j inside of this, okay? So at this point we can just run this real quickly. And here we go. So what we're noticing here is that I prints out and I starts at 0, and then all of j's loop runs entirely. So 0 through 9, so that's 10 objects, or 10 prints. Then we get this guy, which is unindented because we don't have a tab in this one. And so that's going to, now it's incremented to 1. So we've looped 10 times here before we even got to the second iteration of loop I. So basically this for loop gets created and destroyed every single time that we're making one loop here. So obviously that's got some other implications too. So like anything that you declare inside of this loop is going to be created and die every single time that this loop runs. So like if you want something to carry over between loops, you're going to have to declare it outside because of the scope of what this is. So like if we wanted to total up everything that we've seen in here, like we might throw something in, or actually, let me go back for 1 second, okay? So we're going to import time real quickly. And this is just going to be so you can watch this kind of unfold in real time. So all we're going to do here is just say time.sleep. I think in Python this takes in seconds. A lot of programming languages would have their sleep function take in milliseconds, but okay, so this is basically going to be, actually, can we get some IntelliSense on this? Well, whatever. Let's just run it. Okay, so these guys print out, and then we're seeing this every single time. Basically, this is telling this to hold on for like 1 second. So we can kind of see this get built in real time. So in here now we're at iteration, or the second iteration of I, and this inner loop is going up until 9. It completes. Then we go back up to our for loop here. Increment I once. So now it's at 2. And that gets printed out there, and then j continues to loop through here. So we don't really need to watch this entire thing go. I think Control C is normally how you kill this. Apparently not here. Here we go. Okay, so that's kind of like the general idea here with these guys. Let's see, like if I wanted to, let's say I wanted to add up all of these numbers or something silly. So let's try, I don't know. Let's say if I say counter, right? It's equal to 0. What I can do is say then j, or counter plus equals j. So basically what is this going to do at this point then, right? So we start our program. We get in here, I is 0, gets printed out. We've seen this happen a bunch of times. So 0 gets printed out. Then we're initializing a counter at 0, and then there's a for loop inside of here that starts up. Because of the scope, this counter is declared outside of this inner for loop, so this guy can see it, and so can the inner contents here. So every time this is running, then we're going to start out by saying, you know, add 0 to this, then we're going to add 1 to this, then we're going to add 2 to this, all the way up to 9. So here, and then after this for loop, let's print this out, right? We're going to just print counter. Okay, good, I got rid of my sleep because that was going slow. All right. So let's see what happens here. So basically every time this is going to be 45 because we're summing up 0 through 10 in here. And that's because this guy was declared at this inner scope level. So every time that I iterates, this counter gets like completely nuked away. So let's try something else here. Let's just throw this up here. So now we're putting this scope at the global level, right? So this loop can see it. This inner loop can see it. But it's not getting nuked between every iteration of I. Just to make this a little easier to see, let's... Alright, so, and now we've got a print inside of this loop, because remember, with Python everything's going to be tab based, or like white space based, so this is going to print out after j has run every single time, so in between increments of I. So actually, let's leave this print in here, and let's just say I is equal to, and then make this an F string just so it's a little clearer what's happening. And do the same thing here. Okay. So I'm going to run this guy. So we see this again. Alright, so we know that the sum of everything from 0 through 9 is going to be 45. And let's see here. So basically every time this is going to add in 45, right? So this is kind of expected. So I is 0. We're going to run this entire inner loop and sum up all of these things and adding them back into the counter. And this gets up to 45 the first time. Then once we go on to our second iteration, we get I is equal to 1. And so we're going to add in just another static 45, or like an unchanging amount, because there's nothing that's like modifying this. It's like the basic idea of nested loops, though. You just kind of need to be aware of the scope of where your variables are created and where they're seen. And then just remember that like anything that's inside a loop is going to run every single iteration. Okay? So let's move on to our first question here for the problem set. Oops. Okay, so I'm going to just kind of minimize some of these things so we can see this a little better. So basically what we're given here is some starter code, right? So we've got define print 6 stars. Let's just kind of run this guy and see what this does, okay? Okay, so this just printed out 6 stars. We're going to notice here that it starts out with white space. And this is just using as for loop, right? So actually this doesn't even need to have this. We could just put 6 in here and that would be the same range. But anyway, so we're going to start at 0 and work our way up through 5 and not including 6 because of how these ranges are declared, right? So every time we are adding another one of these stars onto here. So again, we can kind of see that we've got, here we go. We have a space and a star, a space and a star, space and a star, and so on. And then this prints this out. This function doesn't have any return. It just prints, and that's all it does. So question 1 is asking us to print out a star square that calls print stars in a loop to produce this following output. So at this point, just kind of pause the video for a sec and try this on your own. Your code's going to go down into this area here. All right, so let's see, how do we do this? So this one's going to just be, this tells us we need to call this function 6 times. So pretty much we can just copy and paste this guy over, right? So we know that we need to have a range or a for loop that runs 6 times. And then this is already doing a print for us. So we just need to call this 6 times at this point. So, and then obviously to invoke this, we're going to need to put this somewhere outside in the global scope. All right, so let's just run this guy. And there we go. It looks a little wonky, but you know, there we go. We've got 1, 2, 3, 4, 5, 6, and there's 6. So we made a 6 by 6 square. And so what's happening in this guy is that, so we've got our loop here. This is starting up. So when I is 0, we're going to go and call this function print 6 stars. That's going to come all the way up here because this first loop can't finish processing until we go here, which means that, remember back to how the call stack works, we're going to push print 6 or print star square onto the call stack and then go up here, and then this guy is the top layer of our call stack basically. So every time that this loop runs, we're going up here to this function. We start out with a blank string, and then we're going to build or iterate through and add on space and star 6 times. And then once that's done, you can see here that the for loop is over because the spacing is different, right? There's a tab here indicating that this piece is inside of our for loop, and then this print is not. And then it prints it out. And then once that's done, there's nothing left to do in this function. So this function name gets popped off the top of our call stack, and then we return to this function, and there's nothing left to do in this loop, so we're going to go back and I becomes 1. We do it again, and that's going to happen 6 entire times. And that's all there is to this first question here. So let's move on to question 2, which is going to be basically doing this same thing, but with a nested loop instead. So we're already kind of have seen this, like how this works, but now we just need to kind of combine the two into one super function. So we can actually just take a lot of this code. So we're going to start here. Let's just take this. We don't need this here. Okay. And then we can take this other guy here. And remember that this is like all inside here happening every single time. So that means this is the outer loop. And then this guy would be our nested inner loop. So what we want to be doing then is have our outer loop here, which was this guy. And then this was the contents of our other function. But we need to put this inside of the loop. Now we're going to run into an issue because both of these loops are using the same same variable I. That is our iterating object here. representing each item in this range. So that's a problem. Like if we try to run this right now, let's do that. We're going to get an issue. Or apparently not. That is super weird. This should have thrown error, I would believe, in any other language. I mean, I guess these are going to just run a bunch of times anyway. But still, or I guess because it's getting reset every time and we're not doing anything with it. I'm assuming that in Python, even if we do this, I'm just kind of curious now. If we just print out I every one of these loops, what are we going to see here? Interesting. Okay, so Python, this is a local copy, or the lowest tier, so it's overriding what this one's value is. Huh. Alright, but anyway, if you were doing anything with these, it would get very confusing very fast, so typically we're just going to change this to be at J. And then print this guy out, and we get the same result as last time. So basically we've just collapsed this. We don't need two functions. That was making it kind of complicated for this particular piece. We're just going to use two different things. So every single time that I loops, we're creating a brand new string that's going to produce one of these guys eventually. And then we're iterating through to add on a space and star however many times. And that's all there is to this question. All right, so let's move on to question 3, which is a little bit more stuff going on here. So we're going to write a function called stars and stripes that will draw an alternating rows of stars, which are these asterisks, and dashes based on two parameters given, number of rows and number of symbols. So this is going to be how many rows to print, and number of symbols means how many times we're going to print out this character or whatever it is that we're working with. Okay, so this one gives us an example here. The following would be produced for this call. Stars and stripes of 6 and 7. So that means that there are 6 rows, and there should be 1, 2, 3, 4, 5, 6, 7 characters in each one, or symbols. So this is going to add in a new constraint here that's a little bit different. So let's start off by kind of taking this code and putting it over in here. All right. So I should have said pause the video, and then right now would be a good time to go and try to do this on your own. But otherwise, for people that have unpaused, let's go back and start working through this. So if we do this, we've got stars and, or let's see, let's call this right now, right? We're going to call 6 and 7, and we know what this output should be. So let's run this, and of course we're going to get, we haven't changed anything yet, so we get our block of 6 by 6 all stars. So that's not good. Part of the problem here is, like, even if I change all of these, like, this is hard-coded to be 6, and that's going to be our first issue. So let's make this first dynamic. We know how many rows, and we know how many things are being printed in each row, so the first step is just going to be swapping in these two guys, right? Because we know that this inner loop is building out how many symbols are in each row, and this outer loop is handling how many rows that we're producing. So let's run this again, and now we have this going, where we have 7 symbols in here, and if we change the parameters that we're passing in, so if I put in 8 by 8, what we should see is that this is producing an 8 by 8 square. So of course these look a little wonky, so the spacing, but anyway, we do have 8 rows with 8 things in each one of them. So that part's good. Now we run into this other issue here of we need to make sure that these rows are alternating. So how might we do that? The first thing that would kind of come into mind here is that we can think of these as this first row is going to be at 0, which makes it an even row, and this one would be 1, because remember that when we're doing these ranges, our iterator is always going to start on 0 and then go up to whatever number, right? It's not starting on 1. That's just not how we do things in programming. So when we have evens and odds like that, that's usually a good indication that maybe we want to use modulus. There's a couple of other ways that come to mind for how we can solve this as well, but let's try this with a modulus approach. So in here, what we could do is say that if I, which is going to be this outer loop, mod 2 is equal to 0, and remember, so 0 mod 0 should be 0. Of course, I got to put my colons here to say that we're in a if statement. So if it's mod 0, that means that we're on an even row, and we want to print out stars. Otherwise, let's copy this guy. We're going to just print out some dashes. Okay? So let's run this and see what happens. And there we go. So just to make sure that this is working with the sample input, let's test this. I'm going to put in 6 and 7. And we see that we have star dash star dash star dash. And this one is producing star dash star dash star dash. And then we have the proper number of things in that row. So that's all there is to this guy. There is a couple of other ways that we can think about this, though. So let's say instead of using modulus, what you could do is outside of this, we could say something like is star row, and we start this out as true. Okay, and then let's change this to if is star row. We're going to print stars. Otherwise, we're going to print dashes. And then what we can do is say that after every one of these I loops, because we remember we've got to print out a bunch of stars here, we could do now, let's say that is star row is equal to not is star row, which means that we're going to just toggle its state, because Booleans only have 2 states, right? So they can either be true or false. If this starts out as true and it's outside of our loop, then every single time that this runs one iteration of I, this is going to flip to false on its first run. So when I is 0, we run through, print out our star row, then at the end of it, we are going to toggle it. So we're going to say that star row is now not true, which means that it's false. And then we run through if star row, which would be basically saying if false, which is not true, therefore it goes to this else statement. And we go and add a row of dashes. So if we're going to run this again, we'll see that we get the exact same output. So it's just an alternative way that we can handle this if you don't like using modulus or that's confusing to think about. So that's all there is for this problem. We're going to move on. Okay, so question 4 is going to be, I think, our last question that's about nested loops specifically. But they kind of keep coming up since we're going to be doing work with nested lists in a little bit as well. So this one is asking us, write a function called increasing triangle that will print out the following pattern based on a provided value n. So what this is saying then is that we start out with, so n is going to be like any number, right? It's just the typical placeholder for some value. So if we put in like 8, this would kind of keep going up until we have a triangle that's going 1, 2, 3, 4, 5, 6, 7, 8. But each one of these rows, we're seeing that it starts out at 1, then we have 1, 2, 1, 2, 3, 1, 2, 3, 4, and so on. So So I think that that pattern makes sense, which means that kind of similar to all of these guys, right? We have another place where we have a for loop within a for loop. But the difference here is that the inner loop is going to get bigger every single time. So take a minute and try to figure this out on your own, and then we're going to come back. So now is the time to pause and unpaused. So let's take a look at how we might do this. So the first thing we need to know is that we need to have some outer loop that is going to go from 0 to n, or actually in this case we probably want it to go from 1 to n plus 1 because we're not starting at 0 here. So let's say I'm going to just call this outer here to make it a little bit clearer maybe. And we're going to have our range go from 1 to n plus 1 because that will mean that, or since we're offsetting our starting point by 1, we're going to do the same thing here, which means that it's going to include whatever the last number was. So if we put 8 in here, this will put this stopping point at 9, which means up to but not including 9. Okay, so at this point we can, this is going to iterate however many times that we want to go. And kind of similar to everything else that we've been doing, we're going to start out, I'm going to just put in like, I'm going to call this guy row. And we're going to start this out as a blank string, so we need to reset this every single time that we're running through our loop. Otherwise, if we don't do that, that's going to, I'll show you what's going to happen in a sec, but it's going to just keep building and building on our row until it makes no sense. So now we need some inner loop, right? And the question becomes, like, what do we do with this? Because we want this to only put one thing in this row first time. When we moved on to the second, we want it to have two things. So if we, what we want to be doing basically is going to be basing this off of our outer loop, because this one's going to start at 1, and if we have 1, we want to only put one thing in that row. If we have 2 as our I, or outer, we want to have 2 things in it, and so on. So what happens if, well, let's try this. Let's have this, our range be outer. And then, let's see, let's go row is plus equal to, and then let's have a f string here, and we're going to need a space, and then we're going to put inner inside here, and then at the end of each one of these, again, we're going to print out row. So let's see what happens when we run this guy so far. Let's put in 4. Okay. So this is interesting. This has 4 rows here, but something's off, right? And that's because, let's see, so we didn't start this out at the proper place. So this came in as 1, so that meant that this range is going to be 0 to 1, or 0. So that was probably the issue here. We want to start this at 1, and we want to, like, let's see what happens here. This is going to be also screwed up, but that's closer to what we're looking for, right? Which means that we just need to offset this guy by 1, because this is not going up to 4. And there we go. So what happens if, so basically, let's see what this is doing. So I'm going to bust out some Excel here. And let's just put our variables in here. Or not output, we want outer, inner, and then row, right? So what we have over here is in outer, this is starting at range 1. So outer is going to be 1, Inner has no value at this point. Row is going to be blank. Then let's kind of continue on through here. So inner gets invoked. Outer is still at 1 because it hasn't changed value. We haven't completed a full loop here yet. This starts out at 1 as well. And then row is going to be a space plus inner. So space plus inner is going to be 1. All right, so in our next iteration, outer hasn't gone up yet. We're still in this inner loop. Inner gets incremented to, or actually no, this one's not going to increment because this loop ends at 2. Or, yeah. So it goes from 1 to 1. So this ends, we print out, and then we're going to go back up here to outer and loop, which means that we're going to auto increment to 2. Go back down here. Let me just snap that to the side here. So inner hasn't started up yet. Row gets reinitialized to blank. And then now we are going into our inner loop. So inner starts out at 1, and it's going up this time to outer plus 1, which is going to be up to 2. So it means that this is going to loop twice, 1 and 2. So this starts out again at 1. And we are going to build our string. Then that iteration ends, and we're going to go back and we're iterating here once more. So obviously we haven't gone back up here and incremented outer yet, but inner is going to get incremented to 2. And we're appending or concatenating on, or this is more of an append because we're doing a plus equal to what we already have built in here, and row is still in play, so we haven't reset it at this point. So we're going to do a space and then another space, or space 1 and space 2, because that was already in this string, and now we're adding on space 2 to that. All right, so then this third loop, we are going, so this gets printed out at this point because there are no more numbers to loop through in this for loop. So we print this out, go back up here. Outer is going to get incremented one more time because we're going all the way up to 4. Inner has no value just yet because we are resetting row. Then we get down to here, and inner again is going to start at 1, but this time it's going to 1, 2, and 3 because we're doing outer plus 1, which is going up to but not including 4, right? So I'm going to just kind of copy and paste all of this stuff because that's basically the same thing that's, or here. These 3 are going to basically be all the same, right? And paste this guy down here. So we've got a bunch of these iterations, but this one's going to now have a new iteration. It's going to be, it loops one more time. So we get all the way up to 3 for our inner, and then we have 1, 2, and 3 that get appended onto here, where this ends. Print that out, and then we're going to loop all the way back up for one last run. So we're going to start at 4, and again, since we haven't, or this entire thing, like inner is not in scope yet because we haven't gotten there. Once this for loop ended, we went back up here, and everything in this loop basically resets. So I'm going to have row is equal to another blank. And then all these guys are basically going to be the same, right? It's going to go in here, 4, 4, 4. This one loops now up to a 4th time, and we have 1, 2, 3, 4. And then that gets printed out. Outer runs out of its range, and then we end up with this being our final product. And at each one of these phases, we had to print here, we had to print here, we had to print here, and I had to print here. So that's what's going on in this if we dissect it. What I was going to say now here is like what happens if we don't reinitialize row or if we put it somewhere else. So let's first try this. We're going to blank it out. So first, immediately we're going to see that this is like, hey, we don't know what this is. So if we run this, we're going to probably get a unbound local error because this guy was never created and we're adding something onto it. If we just set this equal to this, that should be okay, but it's obviously not going to be what we want it to do. If we instead were to put this outside of here, we're going to run into a different issue because this doesn't get reset between each of these outer runs, right? So we start seeing this building off of itself every single time because it's just adding more and more stuff to it every single time that we run through. So it keeps this inside of the row variable, and then the second time through it's going to add on 1 and 2, and then that's kind of what we just keep seeing, 1, 2, 3. We can see these individual pieces that were originally printed out. So just always kind of think about where your stuff is going to be in scope and where it's not, and what value it might be holding between iterations. But for this is the final solution that we're going to come up with. Not a whole lot more to this guy. So now we're going to start talking. 4.04 is our lesson that's going to be on nested lists. So very similarly, the idea here is that, we're familiar with lists. So that's a list of 4 integers. But lists can also be of lists. So I can put a bracket around this. Do that. Let's print this guy out, or we need to give this a name, right? So call this my list is equal to that. Let's print this dude out. And there we go. So it's just a list of lists, which means that, obviously there are going to be 4 inner lists. Let's make these a little bit different so it's like easier to see what's going on. And I'm going to just kind of hard code this for now. We could generate this with a loop, but I want to be able to see everything up here. Okay, so there we go. We've got 1 through 16 in this list, and it's all broken up into separate little lists. So the main thing to go through here then is we know how to index a list, right? So if we go back to this, right? I'm going to just make a very simple list here. So if I want to just print this guy out or grab an individual index, like if I want to grab 4, right? So I can say print out my list 1, and I can pass in -1, or I can do this would be the 3rd index because this would be 0, 1, 2, and 3. -1 is just going to wrap around backwards, remember? So if I print this out, I print out 4 here. If I do the same thing with my list, I'm going to get an entire list, though, because every single index in this outer list is going to be an inner list. So similar to how I grabbed the last element of this guy, I grabbed the last element of this list, and just kind of maybe to make this a little bit easier to read, I'm going to put these down here. And Python's going to be cool with this because it knows that we're still inside a list because of these brackets. So you can kind of this is just got a general tip for formatting. Sometimes this stuff is easier to read if you put a carriage return between things. And like as long as you have parentheses or whatever structure, this one's got brackets for its structure. You can do this with like an if statement as well, where you'd have parentheses. You can break your various conditions up in an if statement. So same thing with nested lists. You can break it up like this. So yeah. So now we can grab different items in here. So let's just go and put this as 3 and run this again just to show you that it's grabbing the same element. But now we have another list. So this is grabbing an entire list, remember. So we've grabbed this entire thing. So what happens if we want to actually just grab like this 15 inside here? So this is the third element of this big outer list, and this is going to be the second element of this inner list. So you can kind of think of these almost like a grid, right? This is like a two-dimensional array. So similar to here, you know, oops, why is this not deleting? I hate Excel. All right, we're gonna just nuke all of this stuff. Thank you, Excel. You are my best friend. All right, so you can kind of think of this as, you know, a two-dimensional array here, or list. Right, so these are all going to be individual. Each row in here is a list, and that's kind of the same way that these are indexed, except they're indexed at 0 instead of 1, because I don't know why Excel does this. I think they think it's human readable. But yeah. And then for each one of those, we have our various elements inside of here. So this is kind of like if you were graphing like an X and Y coordinate scheme or something like that. But the way that we are going to access this then is we just throw in another bracket here saying that we're going to grab this index on top of this one. Because if we think about this, it's kind of like saying we're grabbing this guy first. So in here, we've grabbed an entire list, which was this thing, and we've substituted it. And now we're grabbing the second element of that list that we have retrieved the first time. So if we run this now, we get 15 as expected. If I put in 0, we should get 13. All right, so maybe if I want to grab 7, then what I would do is that this is list 0. This is going to be list 1 in here. So I want to access list 1. And I'm just using, again, parentheses to kind of show that this entire thing is going to run first, right? So I grab this list first. And then I want to grab 7, so I don't want to grab the 0th element of this list. I want to grab the second one. If I run this, there we go. But because of the way that Python executes the order of a priority, I can get rid of these parentheses. It's just sometimes it's easier to see, and I can put that in. And so we get the same thing. So that's all there really is to these nested loops, or nested lists. You have a list of lists, and it functions a little bit more like a grid, as you see here, where you're going to give it basically two different parameters. There's going to be your rows, more or less. So if you think of each one of these inner lists as a row, and then you give it the column that you want to get inside of that row. Okay, so let's move on to this first question in this problem set. So question 5 is talking about we're revisiting the concept of tic-tac-toe, but we're going to do it now thinking of it as a board of where each list in our or a 2D nested list, right? Where each row is going to be a list. So this asks us, write a function that will print out a tic-tac-toe board as a list of lists in a way that looks natural to humans. So for instance, the example board above, so here we go, we have a variable here, example board, should produce, with leading white space, which just means that there's a white space character here, XOX, and blah, blah, blah. Like, so each one of these is going to basically be transplanted over here, or transcribed. Okay, so pretty similar to things that we've been looking at. We know this is going to probably use for loops, or nested for loops. And remember that we can use things like, we can say for every element in this, and that's the power of the for loop, where we don't have to deal with all the nonsense of that we would with like a while loop. So take a minute here and try to figure this out on your own, and then we're going to come back in 5, 4, 3, 2, 1. All right. So let's see, how do we want to approach this? So we can loop through we know how to loop through a list, right? So let's go back over here. If I wanted to loop through, let's comment all that out. If I want to loop through my list 1, let's call these items. We would say for item in my list 1, we print this out, right? So we're printing item out. And if we run this, we're going to get 1, 2, 3, 4 on all different lines, and that's exactly what we get. So what happens if we want to print out, or so if, let's try this now with my list, right? Which has got a list of lists. Oh, whoops. I want to put that there. So Python's going to invoke its default printing function for each one of these. So we have, and we're printing out a list of lists, or we're printing out a list at every level here. So it's going to grab for each item, and whereas this one, every item was just an integer, every item in here is going to be a list. And so it grabs that and prints it out in the default way. So that's not what we want to do necessarily. If we want to print out another list here, so let's just call this guy element or something, in item. And remember, so this is going to grab each one of these items in here and put it on this temporary variable item that exists just for the for loop. So now at this point, item is going to be equal to the 0th index of my list, which is a list itself. And then we can say that for every one of those items inside of this list that gets retrieved, we want to do something. So for every element in that, we're going to maybe print it out. So if we run this, now we have all the numbers printed out in order. Now the power of using for loops in here too is just like if I wanted to, maybe like all these lists aren't going to be the same size. And if you were using like a while loop or something, you might have said, okay, we're going to go from 0 to 3 every time for grabbing each one of these indices. This is just automatically doing like the dynamic portions for you. So this would print everything out. Whereas otherwise you're going to have to, in like a while loop, you would have to start things at like maybe a counter of 0, and it's going to go up to whatever length or like len is of item minus 1, right? So anyway, let's get back to tic-tac-toe. So let's start out first by printing out every this row here in this board. So I'm going to say for row and board, because that's basically what each one of these is going to represent. We're getting an entire board as the object. And let's print out row and just see what this guy does. We're going to have to invoke this with something. So we've got luckily some starter input, and we can just pass an example board, and that's going to come in on this variable board. And if we run this right now, we get like a pretty good depiction here, but it's not exactly matching up to what we want to be printing out according to the prompt. So now what we might want to do then is that every element inside here is going to represent a column, because that's how, like, so if each one of these was a row like this, then this would be, you know, the coordinates here would be basically 0, 0, 0, 1, 0, 2, 0, or this would now increment to 1, 0, because this would be the 0th column. So let's say for cal in row, and then what we're going to just do is maybe, we don't want to print all of this stuff, right? So let's start out a variable called row string. Let's initialize this to blank because, you know, between each run we want to basically nuke it, and we want to be able to append to it. So maybe we'll go row string plus equal, and then we need a space in here. And these are all strings, so we can just do string appends, right? So this is going to be cal. And just to make sure that this is running this guy first before, or we don't want to make, or we want to make sure that this doesn't run first and then it appends column onto it. So a lot of the time I just like to surround stuff with parentheses to know that we want this operation to happen first. I think order of operations is still going to do the assignment last, but it's just kind of a cleaner way for me to think about these things. And then at the end of this, after we've done or finished constructing it, we're going to just print this out. And there we go. So now this is matching up exactly what this output was. Cool. All right, so let's move on to our next question here. All right, so we're going to be writing a function that will initialize a variable sized, and this is saying that it's going to take in rows and columns, monster maze. So kind of thinking back to how we had that monster maze in lab 2.8, you know, it was kind of like a labyrinth setup. So you started out on maybe like the ground level, and then every time you could kind of keep moving further and further down into the maze. So we're going to first initialize everything to nothing, and then use random to randomly place 3 monsters in the maze, signified by all caps monster. The maze, represented as a list of lists, should be returned by the function. Cool, so there's going to be a good amount going on here. So first off, we're going to want to be building our maze, right? And we're going to need a list of lists, and kind of know that our maze is going to look something like so like if I put in a 4x4, or I don't know, let's say a 5x5. Okay. All right, so we know it's going to look something like this if we were going to visualize it. And your guy would start here and then move around. Then what we want to do is that we're going to randomly pick out things and put monster in 3 different spots that are all going to be random, right? So let's start out with this first piece where we just want to build out an entire thing of nothing. So if we think back to how we were handling this tic-tac-toe problem, we can kind of use that. And right now, let's just take a moment, try this on your own, and then we'll loop back in 5, 4, 3, 2, 1. All right, so first off, we're going to be building a maze, and it's going to be a list. And then we know at the very end we want to return said maze. And then we know we have how many rows we want, so we need to insert a bunch of different lists into here. And then we need to put nothing into those lists, however many columns that we have to create the individual rooms in this dungeon. So first off, what we want to do then is we know how to create things of a certain range. So we're going to have, let's say for R, we're going to use R to signify how many rows. In range rows. And then every time that we have a new row, we're going to be needing to build a brand new list. So let's call this row, and we're going to initialize it to a blank list because we're going to be appending a bunch of stuff to it, right? So now, the very first thing that we want to do is we're going to build out all the rooms in here, right? So we need to do however many columns there are that I get passed in. We're going to need to build out that many rooms. So we're going to say for C in range cols, because these are our variables that get passed in. And now what we want to be doing is we're going to append to this guy. So row.append, and we're going to just put the value nothing in here. And then let's run this right now and see what happens. So if we just print out Monster Maze Builder, and we need to pass in some parameters. So, I mean, I was working with 5x5, and we know what that output's going to look like. It should be this. So let's run this and see what happens. So we get a blank list right now. That happened because this row got created, and we never actually did anything with it, so it never got put into this maze. So what we want to do now is we've built out every single cell inside the maze or room. We want to put this row into the maze. So we're going to append row. So let's try running this guy again. And now we've got a ton of stuff in here. It's just kind of hard to read. So maybe just to kind of visualize this better, say if we're, let's get our resulting maze here. All right, so for like level in resulting maze, maybe we want to just print that out so we can see this in a way that makes a little bit more sense. So there we go, we've got our grid of 5x5s. Okay. Cool, so let's now go back to this, and now we need to do one more task in here. We have 3 monsters that need to get placed in. So there's a lot of different ways that you could think about doing this. I think the easiest is to generate all this stuff first and then go back and add the monsters in. So maybe we're going to put a comment here that says, like, you know, generate maze of rows cols full of nothing, just because that's what's happening in this part. And now what we want to be doing is add 3 monsters to random rooms. So let's see. So we need to add 3 monsters, and how do we want to do this? So what we could, one approach is that we just hard code it, right? So we could say we're going to basically need to generate 3 different coordinates, right? So maybe like this one's coordinate would be it's on the first level, and it's in the first room because these are 0, 0, and this would be 1 for the row, and this would be 1 for the column. So if I wanted to add a, if I was going to just hard code where a monster is, I might say, so maze is going to be our overarching thing. Row is dead at this point because it only exists inside this loop. So I could say I want to put a monster at 1, 1, and that's going to reference whatever text is in that particular spot. If I say monster, now let's just kind of run this again, and there we go. I've got my monster hard-coded into that spot. So now we know how to access this. So what we want to do then is generate random coordinates, basically. So what we could do is say something like, well, obviously we're going to need to import random in order to use the random library. So what we could do is say, you know, like rand int is what we've been working with, or maybe what we want to do is check out inside of here what other things that we could use. So just even scanning through this, the documentation, we see this guy, which is rand range, which is kind of what we were working with already, right? Because this is already a range. So let's see what this does. It's going to return a randomly selected element in the range that is equivalent to some sort of choice of random blah blah blah. So this guy seems kind of interesting. Randint is also a very good option here. So one way that we could do this is say like random.randint. Just to make this a little clearer, we'll call this like rand row. It's equal, it's randint, and we need to be from 0 to however many rows we have. But remember, we're going to have to subtract 1 because we're not going up to the, since we start on 0, we're not going all the way up to the max rows. So we could say rows minus 1. And then basically do the same thing, but with cols. We want rand col. Okay, and now what we can do is put in rand row, rand col. So let's run this guy again, and we see that our monster's randomly been placed here. Let's run this a couple more times. Monster's in a different spot. Monster's in 0, 0 this time. So that's working pretty nicely. So we could, at this point, basically just copy and paste this a few times. So we see that we get 3 different things. So that's good. But this is a lot of repetition here. So like, why would we write the same code a bunch of times? Oh, right. I was also going to show you this alternative way. So we can also just say, instead of like typing all of this junk and having to specify all of our different parameters, we could say that random dot rand range and pass in rows outright, because it's going to pick something in this range that we are already working with. And you could do the same thing here. And just to kind of signify that this is working. So that generated the last column. This time it's over here, and so forth. So we don't want to be doing this 3 times. If we had to increment this, maybe we would generate a super large, like 100 by 100, and we needed to place like 30 monsters. That would just get to be exhausting. And so anytime you're doing redundant stuff like that, it's a good time to use another loop. So we can just say for I in, and we just want 3 things, right? We're replacing 3 monsters, so we're going to have a range of 3. And I wrote this wrong. For I in range 3. We're going to put all this stuff in here. Now let's run this. We've got monster, monster, monster. Monster, monster, monster. So that's good. At this point, this is looking pretty close to done. But we're going to run into an issue. So what happens if all 3 of these randomly selected the same room? I was hoping, after we run this a bunch of times, that we might get that case. So let me try running. Okay. Nope, there's 3 in here. But basically the idea here is that, yes, that can happen. We could generate the exact same row and column combination. And in which case that we're going to just overwrite monster with monster. And that's going to be a problem, because then we're only going to have 2 monsters in here, because 2 of them got placed in the same room. And the way that these games work, it didn't register that there's 2 things in that room. Okay? So this might actually be a case where we want to use a while loop, because we want to keep placing monsters until there's 3 of them. So let's instead start out with something that's just going to be, we're going to call this monster count. We're going to start that at 0, because we have 0 monsters in here right now. And so what we could do is say while monster count is less than, so we want, this would be, we need to have 1, 2, 3, so we want this to be less than 4. We're going to generate a random row, and we're going to place this guy. And what we want to do here first is, so in order to place a monster, we want to make sure that we are placing one in a room that has nothing, right? So what we could say is, if this is equal to nothing, now we place a monster. But of course, every time that we place a monster, then we need to increment this count so we get closer to our final amount. So we say plus equal 1. And this is why one of these places where we might want to use a while loop over a for loop, because even though we're placing 3 monsters every single time, we can run into these conditions where we're not picking a good room randomly, and so we need to pick a different room until we get this right. Now, like, you could have some extreme crazy case where this is going to just keep picking the same room over and over, but like generally speaking, it's not the problem, or not. It's not going to be a problem. Like eventually we're going to get there, right? Another way that you can resolve this sometimes is, like, maybe, so maybe this first run through, we pick like this room, right? And we put monster here. And in the second loop, if we generated the same exact room, we could go, okay, in our for loop version, we could say, check this and say, okay, there's a monster in here already. And so what we're going to do is instead try to place it in the next room. So in that case, you're going to end up with another while loop, and we're basically going to move through and then loop back until we find a room that doesn't have a collision, right? And that's what this is called. It was a collision, is the programming term. But this is a little bit easier, I think, to comprehend like what's happening. So we're just basically checking, does this room have nothing in it? If so, we can place a monster here and increment our count. Otherwise, we don't want to be trying to place a monster in the same room, and therefore our count doesn't get increased because we haven't placed a new monster. So let's run this guy, generate, and we can see that, oh, whoops, this should actually be 3, right? Because we have 0 monster, or we could do this as our monster count, or never mind. We want this to be less than 3 is the end thing, because we placed 4 monsters that time. So that's why we always test our code, right? So we have monster 1, 2, and 3, because this is going to place it on the 0th monster, the first monster, and the second monster, which is a total of 3. All right, so that's how we solved this guy. Got 1 left, and this one's got a lot of stuff going on that you don't really need to worry about. It's just going to be kind of, the idea is we're going to be using somebody else's stuff. So this is going to invoke the concept. We're dealing with encryption and decryption, okay? So basically we've got an alphabet here that's defined, and you don't going to need to worry about that necessarily. And there's a key. We have 2 functions that are given. So this is going to be an encrypt function and a decrypt function. This one takes in a plain text. This one takes in a cipher. And cipher is going to just be your encrypted text. Okay. So we've got an example here, and let's just see what this does, right? So let's decrypt or run this guy. And so this took in this string and encrypted it to this value. So this is using something called a Caesar cipher, and the idea here is that, Roman army needed to send messages to each other, but sometimes if their messenger got killed or captured, they could just read the entire thing, which is bad. So they invented this, like one of the very early forms of encryption, which is we're just going to kind of shift all of our characters. So if we have A, B, C, D, the basic concept is that if your Caesar cipher is like a +2 or something, then A, you just add 2 to it, so it becomes C. So every instance of A becomes C. Be D, E, F. So that's like the general idea then, right? So if I put in, I don't know, like hello, then you're going to offset every character by 2. And then if you want to decrypt it, you just shift them all back, right? This one's doing something a little bit more complicated. We can see how this was made, this key. So basically, these are just one-to-one mapping. So every time that we have an A, it becomes a dash. And we can see that, so this had a D as its first character. And so we can see that D mapped to this period. And that's what we see over in here. So that's all that's happening in this, is that each one of these basically maps to its according, or the key character. So make KO is basically taking in this list of alphabet using another random thing, which is shuffle. So let's go look this guy up. And it says that this is taking a sequence in, or shuffle the sequence X in place. So we had a sequence that was a list, and it shuffled it in place, so that meant it modified, because this is a mutable object, so it's just modifying the entire thing and kind of just jumbling all of this up, and then it returns that as a string. So we broke this alphabet into a list, shuffled it up, and then joined it using some of these string functions to create a list out of that. So that was what happened here. That's what these two mean. And then this was an example of how we use this. So you pass in the key and you pass in the alphabet, and it can encrypt it, or it encrypts it or decrypts it. Don't worry about how this stuff is working. It's for a later time. Just know that you can encrypt and decrypt. And this was the example case, so I'm going to comment this back out. So above, we are given some functions that encrypt and decrypt. So see this example usage. Below are some encrypted playlists from Slopify, which is Spotify's crummy competitor. Use the functions above to decrypt and display the full playlist structure in the following format. So it would be a dash, and then playlist 1, and then however many songs are in there, dash playlist 2, and then some more songs, and so on. And these are all going to be different sized things. So here we go. We have a example playlist that is used for debugging. Right, so in here we have a bunch of encrypted things. You can't read them, so we're going to have to decrypt this in order to see it. And again, just kind of format this a little bit so we can see that here are all the different songs in this list theoretically. And then in here, each one of these is going to be a different playlist every time that we have a list inside here. So this is a list of all of your playlists, and each playlist has a list, or is a list of songs, right? So that's kind of how this is looking when we get this out, and this is going to be all complete nonsense. So this is going to be pretty similar then to what we've just been working with, like Monster Maze and some of these other things where we just need to process two different lists at the same time. I guess this is closer to the tic-tac-toe printer. So take a minute here, and we're going to come back in 5, 4, 3, 2, 1. All right. So let's see. So first off, what we want to do is we want to grab each playlist and decrypt them, right, one by one. So we have playlist that comes in. This probably should have been a better name. This is all the playlists that come in. So for every playlist, which is going to be a list itself, so we're going to say for every playlist in playlists, so we're going to grab these one at a time. So I've got a bunch of stuff here. Where did that come from? Anyway. So anyway, yeah. For each one of these guys, we want to be doing, we would need to be running through and decrypting them, right? So let's start with that. We're going to just decrypt, or let's print out everything that we're decrypting. So we see up here how we can encrypt something. So we give it a plain text and the key in the alphabet. So decrypting is going to be a pretty similar process. So we're going to instead do decrypt. And we don't want to pass in this. We want to, right now, actually, we've got our, this is going to be an entire list, right? So we want to grab every song in here. So for song in playlist. So we're grabbing this entire list, and then for every one of these songs, which we can see by these commas, we're going to need to decrypt them because they're encrypted. Maybe, actually, let's even just go a step further and call this encrypted song, because that's what this really is. Okay, so let's just start out by printing every one of these. Inconsistent use of tabs and blah, blah, blah. Okay. So when you see that kind of error, that means that one of these has a bunch of spaces in here, and the other one has a bunch of tabs, or something along those lines, right? Like it wants all the white space to be done the same way. Oh, right, I didn't call anything. Duh. So we're gonna have to go down here and call our function, and we're gonna pass in all of these guys. And there we go. So we can see now that we've decrypted all of these, but it's not done in the right way. So what this is specifying is that it should have this format. So we're actually very, very close already by just running through this and printing things out. What we need to do then is just, I'm going to print playlist, and then we're going to have to put something in here, and this is going to be kind of like an area of confusion, right? Because we don't have anything that represents how many times that we've seen stuff. But for now, let's just keep this as is, and we're going to do an F string of this, and for each one of these songs, we're supposed to be putting that in. And with F strings, you can actually just leave this entire thing in place. So this would be basically the same as, like, you know, we're going to declare this as a variable outside and then do that, or we can just kind of do it all in place. So let me just run this again, right? So now we can kind of see that we have a playlist here, and we can see that the songs are on here, and it's doing this very close to what we want. There's going to be one issue here of we don't have the numbers, because this is specifying that we need to have numbers 1 through however many playlists are actually in here. So what we can do is, oops. I'm going to call this counter, and remember these playlists are starting at 1, and so every single time we're going to put in our F string counter. If we run this right now, they're all going to be 1, right? So this is playlist 1, playlist 1, playlist 1. That's because we haven't incremented this anywhere. So after every loop, we're going to want to increment this. Oops. We're going to want to increment this guy by 1. So counter is going to be plus equal 1. And now we can see that we have playlist 1 is these 3 songs. Then we get playlist 2, and it's got 4 songs in there, and so on. So that's everything for this one. There's a lot of stuff going on in here, but you don't really need to know a whole lot. This could basically be abstracted. You don't need to know how all this stuff works. You just need to know that it's doing its job. Kind of like you don't need to know how print works in the background, how it gets actually stuff from your code all the way into this terminal. You just need to know that it exists and it works. So this is our final solution here for this question, and that is everything in this problem set. So thanks for tuning in. Hope you guys are doing well with all these assignments.